Hello, 5th grade math friends. This is Chapter 4.7, Part 2, More Real-World Problems with Multiplying and Dividing Fractions. Let's get right to it. In our previous lesson, we learned how to find fractional parts of a whole. Today, we're going to find fractional parts and wholes given one fractional part. So here's our first example. Ben took a test with 3 sections, Section A, Section B, and Section C. Ben spent 1/5 of his time on Section A and 1/3 of the remaining time on Section B. He spent 48 minutes on Section C. So how much time did Ben take to complete the whole test? All right, there are 2 methods for solving this problem, and the first uses our bar model. So let's go ahead and draw a bar model that represents the full amount of time that Ben would have spent on his test. So we know that we need to divide our bar model into 15 equal parts. Why 15? Because we have a 1/5 and a 1/3. So let me go ahead and divide that. And now let's begin marking these parts. Ben spent 1/5 of this time on part A, and that's going to represent 3 of our boxes, because 3/15 is the same as 1/5. Now Ben spent 1/3 of the remainder on part B. So how many parts do we have left? Well, we'll have 15 minus the 3 that were spent on part A, so we have 12 left. So 1/3 of 12 is 4. So 4 will be spent on part B. He spent 48 minutes on part C. That's what we have left. So to figure out how many minutes each section is worth, we'll say that 48 minutes is equal to 1, 2, 3, 4, 5, 6, 7, 8 units. So 1 unit of time for the test is equal to 6 minutes. Okay. So our question was, how much time did Ben take to complete the whole test? Well, it'll be 48 minutes right here, correct? And then we'll take 1, 2, 3, 4, 5, 6, 7 times 6 to figure out the amount of time spent on this part of the test. So 7 times 6 is 42. So he spent 42 minutes on parts A and B together and 48 minutes on part C. So our total test time will be 42 plus 48 equals 90. So Ben spent 90 minutes or an hour and a half on the test. Now let me show you method 2. In method 2, we're going to skip drawing the bar graph and work only with computations. So we begin once again with Ben taking his test with parts A, B, and C. 1/5 of his time was spent on part A, 1/3 of the remainder was spent on part B, and 48 minutes were spent on part C. So the first thing we'll do is we'll work from what we know to what we don't know. So we know that Ben spent 1/5 of his time on part A. That means that he spent 4/5 of the test time on part B and part C. I get that 4/5 from taking 1, which represents our total time, and subtracting away 1/5, which is the time he spent on A, leaving us 4/5 of the time to be spent on B and C. He then spent 1/3 of that time on section B. So the first thing we'll calculate is what is 1/3 of 4/5. And this tells us that Ben spent 4/15 of the time on part B. Now we know 2 pieces of information. We know how much of the whole time was spent on part A, and we know how much of the full time was spent on part B. So we can add 4/15 and 1/5 together to get the amount of time that Ben spent on part A and part B together. So we'll add 1/5. I'm just going to go ahead and convert this to an equivalent fraction now and make it 3/15 plus 4/15 to get 7/15. So now we know that Ben spent 7/15 of the total time on parts A and B together. All right, now we work with the last piece of information we have, which which is that Ben spent 48 minutes on part C. If Ben spent 7/15 of the total time on parts A and B, then that means he spent 8/15 of his time on part C, and 8/15 of the total time equals 48 minutes. Do you see how that works? Okay, so now, once again, we'll solve to find out how much 1/15 would be worth. And we do that by dividing 48 by 8, right? So the answer will be 6 minutes. So now to find out what 15/15 or the whole time would be, I'm sorry, I ran out of room, so I'm going to move up to the top here. To find out what 15/15 would be, we take 15 times 6, and that gives us 90 minutes. So Ben spent 90 minutes to complete the test. Let's tackle a fresh problem using both methods 1 and methods 2. Jermaine prepares a mixture of apple, carrot, and strawberry juice. I'm going to mark that as apple. It was A, carrot as C, and S as strawberry. Of the total amount, 1/3 of the mixture is apple juice. 2/5 of the remainder is strawberry juice. And Jermaine used 315 milliliters of strawberry juice to make the juice mix. So what amount is carrot juice? This one's a little different, isn't it? Okay, so let's tackle first by drawing a picture using a bar model. So this bar model represents the total amount of juice that Jermaine made. I'm going to divide it into thirds because I know that this third is apple juice. Here's the remainder. Now I need to figure out how to mark 2/5 because 2/5 of the remainder of this 2/3, 2/5 of the 2/3 left is strawberry juice. So I need to find a common denominator. My common denominator for 3 and 5 is going to be 15. So let me split this into 15 parts. Remember, I have to do this one too for my common denominator. And I'm going to give 4 of those parts to strawberry juice, right? Because 2/5 or 4/10 of our remainder will be strawberry juice. Do you see why I use tenths? We already know that 5/15 are apple juice, so we're just working with the tenths right now. So 1, 2, 3, 4 of these are strawberry juice. So carrot juice equals 6/10 or 3/5. So 3/5 of the remainder is carrot juice. Now we also could have figured that out just using math, and I'll show you how to do that when we move on to method 2. So what do we know? We know that 4/15 of our mixture equals 315 milliliters. So if 4/15 are 315 milliliters, then 1/15 of our mix will be the same as 315 divided by 4, which is, it's going to be a slightly weird answer. It's 78 3/4. So each one of these units up here represents 78 3/4 milliliters of juice. So how do we figure out how much is carrot juice? We take 1, 2, 3, 4, 5, 6 units. Sorry, I've run out of room again on my screen. Times 78 3/4. Okay? So remember, we have several different ways we can multiply this. I'm going to go with the straight and simple way. I'm going to take 6 times 78. And then I'm going to add that to 6 times 3/4 to give me 468 plus, let's see, 18/4. Or, hold on, we need just a little bit more space here. 18/4 can be rewritten as 4.5. So this becomes 472.5. So the quantity of carrot juice is 472.5 milliliters. Okay, now let's solve this same problem without using the bar model, just using the mathematical thinking. Let's quickly review our quantities. Jermaine prepares a mixture of apple, carrot, and strawberry juice. The apple juice is 1/3 of the total amount. The carrot juice is something we don't yet know. And the strawberry juice is 2/5 of the remainder. It is also 315 milliliters. All right, so there's all the info we have. As always, let's begin by identifying what we definitely know. We know that we have a quantity of juice and that 1/3 of that juice is apple juice. And that 2/3 of that juice is a mixture of carrot and strawberry juice. Okay? Of that 2/3, 2/5 of that juice is strawberry juice and the rest is carrot juice. So now we can figure out how much of the total quantity of juice is strawberry juice by taking 2/3 times 2/5. 2/5 of 2/3, which represents carrot plus strawberry together. So 2/3 times 2/5 gives us 4/15. So 4/15 of the total amount equals 315 milliliters because 4/15 is the quantity of strawberry juice, which can also be described as being 315 milliliters. So here we are, right exactly where we were in the other problem. We want to know what 1/15 is, so we have to divide 4/15 and 315 by 4, okay? So what's 315 divided by 4? Well, we figured this out in the last problem. It is 78 3/4, okay? So now, how much is carrot? Well, if 4/15 is strawberry juice and 1/3 of the total is apple juice, then we can add those two together to find out what quantity or what fraction of the total is carrot juice. So let's do that. Let's add 1/3 plus 4/15, which is the same as 5/15 plus 4/15 or 9/15. So 9/15 of the juice is apple plus strawberry together. So if we use 1 to represent the total quantity of juice and subtract 9/15, we have 6/15 left. So if 6/15 of the juice is carrot juice, we can find out how many milliliters of carrot juice we have by taking 6 times 78 3/4, which, as we discovered in the last problem, gives us an answer of 472 1/2. Okay, let's tackle another one. These get tricky, so if you're feeling impatient or frustrated, don't worry. We're going to practice more and keep giving you more examples until it does click. So here's our next problem. Gomez collects stamps as a hobby. He gives his cousin 1/3 of his stamp collection. He then gives his sister 5/6 of the remainder. And he has 80 stamps left. How many stamps did Gomez have when he began? Okay, let's begin with drawing our bar model. So let's draw a bar that represents the total quantity of stamps that Gomez had when he began. He's going to give 1/3 of those stamps to his cousin. And he's going to give 5/6 of the remainder to his sister. Well, we can see if there are 2 sections left. We clearly need to divide those into thirds. And remember, we got to keep a common denominator, so do it to the cousin's section too. And 5 of these go to his sister. So this quantity is 80, right? That's going to have to equal 80 stamps because that's what Gomez had left when he was done. So how many units of stamps do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. The question is, how many stamps did Gomez start with? So 9 units times 80 stamps will give us our answer. Gomez started with 720 stamps. Whoa, that one almost seemed too easy, didn't it? Okay, let's try it again without the bar model and see if it looks as simple. All right, let's begin again by putting our facts down. So Gomez collects stamps. He gives 1/3 to his cousin. He gives 5/6 of the remainder to his sister. And he has 80 left when he's done. All right. So let's figure out what we've got going on here. So he gives 1/3 of his stamps to his cousin. That means he has 2/3 of his stamps left, right? Then he decides to be really nice and give 5/6 of those stamps to his sister. So 2/3 times 5/6 will tell us what 5/6 of 2/3 is. So let's go ahead and solve this. So this will give us 10 over 18 or 5/9. Okay, so at this point, Gomez has 5/9 of his stamps that he's given away to his sister. So now we can calculate the total number that Gomez has given away. He's given 1/3 to his cousin, plus 5/9 to his sister, which we would rewrite as 3/9 plus 5/9 equaling 8/9. So Gomez has given away 8/9 of his stamps. That means that 1/9 of his stamps is also equal to 80 stamps. So 1 unit is valued at 80. To calculate how many stamps he began with and answer our question, we simply need to know the value of 9/9, which would be 80 times 9, or 720 stamps. Okay, there's one final type of problem to introduce before I let you take off on these on your own. Here we go. In our last type of problem for today, we're going to figure out how to find fractional parts of a remainder when given a whole. So Alana makes 4/5 of a gallon of lemonade. That's our whole, okay? That's our total amount we're starting with, is 4/5 of a gallon. She pours 1/4 of the lemonade into a pitcher, and the remaining lemonade equally amongst 6 glasses. How much lemonade is in each glass? Oh boy, this is tricky, but we can do it. Let's begin with a bar model. That's method 1. As always, bar model is method 1. So I'm going to start by drawing a bar that represents 1 gallon of lemonade. I'm going to divide it into 5 equal parts, and I'm going to X this one out because we don't really have it, do we? We only have 4/5 of a gallon. So Alana pours 1/4 of this lemonade into a pitcher. I'm going to label one of these sections with a P for pitcher because the other 3 are going to get poured into glasses. So now she's going to pour what's left into glasses, 6 glasses to be exact. So we have 3 segments to go into 6 glasses. Each needs to be divided in half. Don't forget, we need to divide the part of the gallon that isn't there and the part of the gallon that went in the pitcher in half as well so that we keep a common denominator. We're changing this from 5ths to 10ths. So our model shows us that 10 units equals 1 gallon, right? So we have 10 segments, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, equaling our 1 gallon of lemonade. So each unit is 1/10 of a gallon, right? So how much lemonade is in each glass? Well, 1/10 of a gallon. Okay, see how that works? Now let's try this using method 2, which only uses the math instead of using the picture. Let's review our facts. We have 4/5 of a gallon of lemonade. 1/4 of that 4/5 is poured into a pitcher. And the remainder is divided equally amongst 6 glasses. All right, so let's figure this out. We start with 1, representing our total quantity of lemonade. Just like we would draw one bar model and use that to represent the full quantity, 1 is going to represent our full quantity here. We're pouring 1/4 of our gallon of lemonade into a pitcher. That leaves us with 3/4 of our 4/5 left. Did you hear how I said that? We have 3/4 of our 4/5 gallon left. So the amount that's going to get poured into the glasses is represented by 3/4 of 4/5. So let's multiply that across. This is cross divisible, giving us 3/5, because it would be 3 times 1 and 1 times 5. So 3/5 of the lemonade is the amount that'll get poured into glasses. That 3/5 is going to be poured into 6 glasses, so 3/5 divided by 6. Send this through the reciprocalinator, 3/5 times 1/6 And we get 3/30 or 1/10. Ta-da! There's a 1/10 of gallon of lemonade in each glass. Let's try one last problem like this before I give you some practice problems to try on your own. Jeff buys 3/4 of a pound of beads. 1/6 of the beads are pink, and the rest are green. So right away we can say that 5/6 are green, right? Because if we have a total of 1 and 1/6 are pink, then 5/6 have to be green, correct? Jeff packs the green beads equally into 10 jars. So what is the weight of the beads in each jar? Okay, let's begin this problem by drawing a bar model. We'll begin by drawing a bar model that represents a pound of beads. So we'll divide that into 4 equal parts, knowing that this part we don't really have. But remember, since we're measuring out of pounds, we have to keep that imaginary 1/4 pound there. Okay, so we have 3/4 of a pound of beads. 1/6 of them are pink. So we need to divide our thirds into 6. So we'll multiply by 2. And don't forget, we have to do the same to our non-existent 1/4 of a pound so that we keep a common denominator. 1/6 is pink, and the rest are green. All right. Now that we can visualize this part, let's move on to solving the next part of the problem, which is to divide our green beads into 10 jars. So we now have 1, 2, 3, 4, 5 sets of green beads that we need to divide into 10 equal jars. So we have 5 sets that need to go into 10 jars. That means half of each set, half of each set is going to go into each jar. I also need to divide this because we need to keep a common denominator. So now let's count what we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So let's see. Of our green beads, we have 10/16. So our green beads represent 10/16 of a pound. Does that make sense? I hope so. So now let's move on to the next piece. If our model shows that we have 10/16 of our beads being green, and we're going to divide those into 10 equal jars, that means we need to take 10/16 times 1/10, giving us a final weight of 1/16 of a pound. So each bag of green beads is 1/16 of a pound. Now let's go on and learn method 2. Let's review the basic information to start. Jeff buys 3/4 of a pound of beads. 1/6 of 3/4 of that pound is pink. 5/6 of that 3/4 of a pound is green. So now he's going to divide the green beads into 10 equal jars. How much does each jar weigh? Okay, so let me show you how to figure this out using the math. Okay, so let's look at what we know. We know that 5/6 of 3/4 of a pound is green beads. So let's solve this multiplication problem because it will tell us the weight of all of the green beads together. So let's see, we can cross reduce 6 and 3, each are divisible by 3, giving us 5/2 times 1/4, which gives us 5/8. Okay, so 5/8 of the beads are, 5/8 pounds of the beads are green. Now we're going to divide that 5/8 pounds of beads into 10 equal jars. So let's send it through our reciprocalinator, which gives us 5/8 times 1/10. We can cross reduce. Both 5 and 10 are divisible by 5, giving us 1/8 times 1/2, or 1/16. So each jar of green beans weighs 1/16 of a pound. I think you're ready to try some of these on your own. Here's the first problem. Mr. Young has a piece of rope. He uses 1/4 of it to tie some boxes together. He uses 5/9 of the remainder to make a jump rope for his daughter. After this, 120 centimeters are left. What is the length of rope that Mr. Young used to tie the boxes together? So, if we have one length of rope and the remainder is 120 centimeters, what was 1/4 of the original length? Give it a try. If you get stuck, no worries. We'll work through it together tomorrow. Press pause while you work, and I have 2 more problems for you to try after this one. Sean has a piece of string that is 7/8 meters long. He uses 1/5 of this piece to tie a package, and then he cuts the rest into 5 equal pieces. So the remainder into 5 pieces. What is the length of each piece? So how long is each of these 5 pieces? Once again, give it a try. If you get stuck, don't worry. We'll work through it together tomorrow. Press pause, and there's one final problem after this one. And here's your final problem for today. Callie bought a bag of dried fruit. The bag contains cherries, pears, and apples. In the bag, 1/4 of the dried fruit is cherries, and 2/3 of the remainder is pears. There are 48 pear pieces. How many pieces of fruit are apples? Okay, give this one a try. It's tricky, but there's a problem just like it earlier in the video. You can go back and review if you get stuck. If you get stuck completely, don't worry. We'll work through it together tomorrow. This brings you to the end of this video, so I'll see you tomorrow where we'll do lots of practice on word problems just like these. Have a great night.